Hello, this is Jacob Hawkins, and I am presenting on our fifth Interactive Advanced Concept presentation. This week we are going to be doing penny chemistry. So I've set up this presentation a little bit different from ones in the past. I'm going to dive right into the videos just because there's kind of a lot to cover, and then I'll talk about the concepts that are kind of going on behind the scenes towards the last few slides. Hello everyone, this is Jacob Hawkins, and I am presenting on our Interactive Advanced Concept presentation number 5 for General Chemistry 1. So this week we are going to be doing an experiment with pennies where we are going to make a solution of vinegar and then salt. And we're going to take some dirty pennies, put those into the solution to essentially clean them, it sounds like. And then we're going to do different things with the remainder of that solution. So we'll add some clean bolts to the solution and basically transfer that rust or that grime onto the bolts. And then we'll also see kind of like what happens with the pennies when we remove those from the solution. We're gonna clean some of those pennies in water, and then others we're just gonna leave to kind of air dry once we take them out of the vinegar and salt solution. So I'm gonna make 2 videos out of this. The first one, I'm just gonna set up the solution, and then for the second video, I'll kind of have a different view so we can see what's happening with those metallic objects a little bit better. So just for the setup, I have some different materials here. I have my pennies, obviously. So I have 6 sets of some very dirty pennies. I don't know how well the kind of grime will appear on camera, but just to kind of show a comparison, this is a penny that I already kind of cleaned in this experiment previously, so you can see the difference, how they kind of gleam. Then we're gonna have our clean bolts here. And then the solution is very simple. So I have 1/4 of a cup of vinegar that I'm going to add to a bowl here. Then I just have some regular salts, and we're going to mix those things up. And then for the second part of the experiment, I just have some plain old tap water here that we'll use to clean off the materials when we're ready. Okay, so I am dissolving the salt into the vinegar completely, and I'm using a plastic spoon just because obviously metal is the thing that we're kind of playing with today, so we don't want to introduce metal that we're not doing anything with, right? Okay, so that's all dissolved. So I'm going to take my pennies, my dirty pennies, I have 6 of them, and I'm just going to place them in here. Make sure that they're all the way covered. All right, so I'm going to switch to a different view, so stay tuned. On the next slide, you're going to actually see what's happening with the pennies. All right, everybody, welcome back. So we are about 5 minutes into the future now. So I would say that this took longer than I expected for the reaction to actually happen. So I didn't want to bore everyone by just kind of, looking at the solution. Honestly, I don't even think that it really captured itself on camera, so I figured the best way to kind of show it was by having some comparisons. So to remind everyone what we started out with, these are 2 of the original 6 pennies that I used. So as you can see, they're very, very dirty, very grimy, and I would say that probably all of the pennies I used were about that level of dirtiness. So I put 4 of those pennies into the solution, which is vinegar and water. 2 of them, vinegar and salt, not water. 2 of them, after I would say about 2 minutes of the reaction occurring, once they looked really, really clean, I put into just regular water to kind of wash them out. And then 2 of them I allowed to air dry. So to pull these out now, just to kind of see the difference. Okay, so air dried, and then washed with water. And then what I did is I took a bolt. So this is what I took. I have 2 bolts. This is basically the same level of newness that the other one was. And I put one of those bolts in here basically to allow that, the rust and the grime and everything to then get onto that bolt. So just to show you, let me get a little bit closer here. So what we see is that with the air-dried ones, when we allowed that, the salt and the salt and vinegar to then be exposed to air, what we're seeing is malachite form. So that's that little green dot. For some reason, this one, not so much, but I have noticed it's looking different as time goes on. So maybe this one will kind of look more like that one. And then just to show you, these are the water wash. So this is the one where we put them in water, so essentially the reaction was stopped. And again, let's just put one of the originals next to it so you can see that for comparison. So this one is obviously a lot shiny and cleaner. Now here, excuse me, I have a frog in my throat today. Well, that's not gonna work because I'm just gonna have to get my hands dirty. All right, so there we have now a very dirty, rusty bolt. So just to show you comparison-wise, this is how shiny it was to start with, and now you can see it's very dark and grimy and gray. All right, so there we have it. So on the last slide, I'm gonna go ahead and kind of summarize what happened and make some theories about why it happened, so stay tuned. All right, so let's break down what was going on in that experiment. So to start off with, the pennies, before we treated them with anything, I was referring to them as being grimy and dirty, but more specifically, those pennies looked that way because they were covered in copper oxide. Now, metal oxidization is an ionic chemical reaction that happens on the surface of metals where electrons leave metals for oxygen molecules that are just in the air. Now that is obviously going to cause a difference in charge, and what's going to happen is the oxygen anions are going to enter the metal that have a slightly positive charge and then create oxide on the surface of that metal. So in our case, because pennies are obviously made out of copper, the result will be copper oxide. So we then made a solution where we took sodium chloride, for me it was just regular table salt, and then acetic acid that's in distilled vinegar, and we're mixing those together. And the resulting solution is very good at dissolving metal oxides. So when we put those untreated pennies into that solution, what was happening is that copper oxide, and then also just some of the copper from the pennies, is ionizing in the salt and vinegar solution, and it's producing cations that are then just kind of suspended in the solution. So when we removed those pennies and then we put the clean steel nut into the solution, what was happening is that the iron in the steel is ionizing into cations in that solution, and it's leaving behind a slight negative charge in the metal. Then what's happening is the copper cations that are in the solution from the pennies are attracted to the iron, and then they coat the surface of the steel nut, resulting in that kind of dark metallic look that it had after the treatment. So as for the pennies, when we removed the pennies from the solution, a few of them we put right away into the water. And by washing those pennies in water, we're getting rid of the remnants of the the vinegar salt solution, and we're kind of neutralizing it. So no further reaction is going to happen. So when we took them out and we put them on the paper towel, they're just nice and clean, and they're going to probably remain that way for a little bit of time before just natural oxidization happens with average exposure to air. But with the other pennies that we did not wash off, by leaving that residual solution on the pennies, it's allowing those freshly exposed copper atoms to oxidize right away when they're exposed to the air. And then it produces that green surface that is called malachite. Now, one thing I noticed is one of the pennies kind of had that blotch of green that was growing on it, whereas the other kind of just stayed. It was a little bit darker, but it didn't really get that green look. And I'm thinking that what happened is because when I put it down on the paper towel, I think I actually flipped it. And by doing that, probably a lot of that solution just got, wicked away from it and it dried off. So I believe that that's why the one penny reacted a little bit more strongly than the other, even though I was expecting both of them to oxidize quite quickly. So I hope everyone enjoyed this experiment. Another really super simple, easy at-home one. And I look forward to observing everyone else's experiments and seeing their results.